Now, we want to determine the volume of the solid that is formed, the solid formed when y is equal to root of x is rotated about the x-axis. So we are going to sketch this. We have the x-axis and the y-axis, and this curve y is equal to root of x is around here. So between 0 and, for example, 1, we want to see the volume of the solid that is going to be formed. So this is something that is going to be formed when I do what? I rotate this around the x-axis. So what is going to be defining the radius is actually y, and therefore we need to look for area first of all, and our area is equal to pi y squared. So this is pi, the y is root of x, so I square, and that area is going to be defined by pi x, because root of x squared, I'll have it as root of x, meaning that volume will equal to integrating this pi x from 0 to 1. 0 is there with respect to x. So that volume will be pi x squared out of 2 from 0 to 1, and this gives us pi out of 2 minus 0. So volume is pi out of 2 cubic units. So this is something that is very, very, very simple for you. Let's also look at an example like this. If you have a curve y is equal to x squared, y is equal to x squared, and you want to get the volume, this is y, this is x. You want to get the volume of the solid formed when this is rotated around the x-axis. So that means this is something that we are talking about. So the radius is going to be also defined by y, and therefore the area will be pi y squared. But y is equal to x squared, so this becomes y is equal to x squared. So area will be pi into x squared to power 2. So area will be pi x to power 4. So meaning that if I'm talking about from 0 to 1, okay, my volume will be integrating of this area with respect to x from 0 to 1, and this is integrating from 0 to 1 of pi x to power 4 with respect to x, and therefore volume V will be pi integrating x to power 4, it becomes x to power 5 divided by 5 from 0 to 1, and that becomes pi out of 5 cubic units. Even if I subtract this one with 0 substituted, everything is 0, so I still don't want to waste my time. So I just substitute in pi out of 5 into 1 to the power 5, and 1 to the power 5 remains 1. So 1 times pi r. So the whole thing remains pi out of 5, and that is in cubic units. So here we are saying that sometimes solids can be formed when we have two curves intersecting, okay, at different points. They could be intersecting at 2 points, and therefore the solid formed in between them, it can be a washer when you look at its cross section area, and therefore you'll find that this washer has internal radius R1 and outer radius R2. So in most cases, when you want to get the volume, you will find that you are subtracting the two, and therefore you are talking about this area is the one you're looking for. Now let's look at an example of that case. So take a function, consider curves y is equal to x squared, and line, and the line, by the way, line y is equal to x. Now if you have such a scenario, you have y is equal to x squared, then you have line y is equal to x. So this is x squared, this is y is equal to x. So the area we are talking about is this area. When you rotate it around the x-axis, you'll form something that looks like a washer. So, but what happens here to get the volume? Obviously, what we are going to do, we are going to first get the y value. From there, we can integrate the different areas being subtracted, and we proceed. So what am I saying? I'm saying that area, for example, area A1, for this, you'll have pi, okay, maybe y1 squared, which will be pi into x squared, then squared, this becomes pi x to the power 4. Then you have area A2, which is pi y2 squared. This is pi into, this is x, so x squared. So you have pi x squared. So what does that mean? If I'm talking about an area between or region between 0, 1 and maybe 1, if I find out that actually the two are intersecting at 1, or I'm just looking at the region from 0 to 1, then I can say the volume of the solid will be integrating area A1 with respect to x minus integrating area A2 with respect to x. So that volume will be integrating from 0 to 1 of pi x to the power 4 with respect to x minus integrating from 0 to 1 of pi x squared with respect to x. So this volume will be pi into, this is x to the power 5 out of 5 minus, this is x cubed out of 3. So from 0 to 1. So this becomes 1 out of 5 minus 1 out of 3, everything times pi. So volume will be, this is 15 divided by 5, that is going to be 3 minus 15, okay, divided by 5, is going, divide by 3, I'll get 5 divided by 15 pi. So this becomes negative 2 pi out of 15. What does this tell us? It means actually the volume is this minus that. And therefore, we take the absolute volume or the magnitude. So that volume should be 2 pi out of 5 cubic. So that's how we can get the volume if we have that solid formed between a line and a curve. Even if there were two curves, still the narrative would be the same. The method won't change really any much. And that is how we can deal with such problems. Let me assume, let me see which kind of